Thank you, everyone. So I already didn't trip on the step, which is a big win for me. So thank you very much for having me today. Welcome back from the coffee break. It's always nice to have an audience of caffeinated people looking at my presentation. What could go wrong? So thanks a lot to the Open Reality and Ekahau team for having me today. We're going to take a look at a recipe for high-density deployment with 9800 wireless controllers, Catalyst controllers. So, apologies for what I'm going to do next. Wi-Fi is never a perfect shape, but sooner or later we all came up to that paper plan with the access points drawn with a circle around them to try to visualize Wi-Fi. So I will need to use that a few seconds to set the stage, to use those perfect shapes, although as we also saw earlier on in the morning, that's never the case in design. So, a couple of words about the presenter. My name is Federico in Italy, where I come from. We can shortcut it to Fede. It's easy to call out and remember. I've been in Cisco since we had that kind of nice oldie logo there, and I've always been focusing around wireless, and network access control is my other passion. And when I'm not working for Cisco, well, I'm working for my whole family doing IT support. So laptops, mobile devices, routers, channel planning for the neighbors of my apartment, whatever I can do there, you name it. And since we have some very common grounds, very nice common grounds between Italy and France, well, that's where they kindly adopted me, and that's where I'm living and working today. So I accept jokes on both cultures, absolutely. No offense intended at all, okay? And it's funny that it's the Italian presenter starting a little bit late today. So, going back to those perfect shapes there, one of the main challenges we often face with high-density deployment, but not necessarily just with high density, we could apply that also to other kind of environments, such as warehouses or whatnot, for example, is that, well, ideally, we would like to cover specific areas, maybe as also Matt showed this morning with smaller cells. We tend to typically go for those directional antennas. That would be our ideal situation. Now, as mentioned, Wi-Fi is never a perfect shape, so those directional antennas, they have, of course, side lobes. We're actually taking advantages sometimes of those leakages and side lobes, so to speak, for the access points also to exchange some neighboring messages and to synchronize with one another. Okay, so depending on the different solutions, we are, let's say, calling those messages in different ways, but they are useful for the access points to sync up and to do some automatic channel planning, transmit power assignment, etc., etc. Now, the difficulty, the challenge comes from the fact that usually for high density, or again, other type of environments as well, usually the access points are installed at some height, and at those heights, the access points may start getting a little bit packed together. Okay, so the height at which they are installed, it's usually becoming quite, let's say, higher than the distances between the access points. So we end up with a situation with kind of many access points potentially up there in those heights. They can, well, speak nice to each other. They are hearing each other very well. So they may decide that in the end, they don't really need to talk that loud anymore. Everyone is hearing each other fine. So transmit power assignment may get automatically reduced, and the clients on the ground are not that happy anymore, okay? And that's usually when the high-density deployment starts going a little bit bananas there. So this is the kind of challenge we are facing, the thing we are trying to sometimes avoid with high density and some other use cases, all right? Now, to see, let's say, how to address this, well, if you would like to extend your coffee break, you could tell me, okay, I can leave this session now, I will manage my transmit power manually, and that's it, which is perfectly fine. I totally accept the option, I totally agree with the option. In some cases, we can do that manually. You can go back to the coffee. This session has ended. But there are some situations where we would still like to keep those transmit powers automatically assigned and also avoid that kind of conflict with access points, reducing the power a bit too much. So a typical example where we are trying to make those things coexist. It's an event we are holding at Cisco, which is called Cisco Live. So it's usually our biggest public event. It's being held 3 times a year, one in Europe, one in the US, and one in Australia for the 3 main world regions. Depending on the event, we may have more or less density of clients. We're using few pairs of controllers to manage the network. And well, for the example that of the event that we just had in Amsterdam in February, it was a bit over 700 access points, okay? Do we need all those access points? Not always. But we like to do things, to play around with stuff, to test some new things. And one important, let's say, point of that event, and apology for the bad joke here, Cisco Live is quite a lively event in the sense that it lasts a week, but even during the event, we may still tweak things, okay? So that's the typical example of my colleague, Jakob, who will present this afternoon, by the way, who a couple of days into the event had to go and replace few tens of access points, okay? We decided we should replace those access points, maybe move them a little bit around. And while doing all those changes, we don't want to, let's say, bother with adjusting channels or transmit powers manually, okay? We would like to keep it as automated as possible. We trust the algorithms of the controllers to do that, but we still like to control them in some way, all right? So the way we'd like to control those algorithms is through the configuration model of our 9800 wireless controllers. And I would have to go a little bit into the details of the configuration here. But we could apply this principle to many other Wi-Fi installation and networks there. So in the 9800 wireless controller, we have 2 main objects we exploit to configure it. One is called a profile, and the other is called a tag. A profile contains the settings we'd like to apply, and then the tag takes 1 or more profiles and assign them to the access points so that the access points are inheriting those settings. So we have, for example, WLAN profiles for the SSID settings, policy profiles for the traffic policies settings. We can push them to what is called a policy tag. Similarly, for AP settings specific, we have what is called AP joint profiles. We put them into site tags, but we also have what we call RF profiles, okay? RF profiles are used specifically for RF. Optionally, we also have something called radio profile. Those are put into an RF tag, and then we can go and tag all our access points we want with those tags to apply the settings to the access points. Now, without this going too overboard, we're going to focus a little bit on those RF profiles and RF tags. So those are 2 of the things we're playing a lot with at Cisco Live, but at many other high-density environments, or even at any other wireless installation, actually, all right? So what does an RF profile look like? Well, it's a configuration object, so graphical interface, command line interface, an external automation tool with netconf and YANG, whatever we prefer. But it's basically a profile we apply to one of the 3 bands, 2.4, 5, or 6 gigahertz. Now, for the event in question, we are using 5 and 6 gigahertz only. We can tweak a lot of nice things through the RF profiles. Lowest mandatory data rates. So in high-density deployment, we like to bump up the lowest mandatory data rate to keep the cells a little bit smaller. Channel width. We're keeping 20 megahertz channel width everywhere on 5 gigahertz. We don't even think about going beyond that for high density. Or even some more advanced stuff, like the receiver start of packet detection threshold to make the access points a little bit less sensible to signals that are maybe too far away. But there is one cool setting we'd like to include into our RF profiles, and which is precisely the minimum power level at which we allow an access point to go. So there are a set of algorithms in a 9800 wireless controller, which is called RRM, Radio Resource Management, that are in charge of automatically assigning channels and transmit powers. The one in charge for reducing automatically the transmit power is called the transmit power control. So by going into the RF profile and telling, for example, the controller, for this RF profile, for access points that we're going to assign to access points installed at medium height, for example, we don't want the transmit power to go below a certain threshold. Now, what that threshold would be, it's completely empirical. We found some thresholds that are working fine for the event. For example, for the event venue at Cisco Live, they may not be exactly the same for other venues. So we are spending, of course, sometimes surveying, going around with sidekicks to, let's say, find the best values we should type in there. But once we found them, we can, well, factor them in our RF profiles. So to stop the access points from going too low with their transmit power. So now that we have the RF profile, we're going to put it into what we call an RF tag, and we're going to assign that RF tag to our access points so that they can inherit those settings. Now, how do we assign RF tags to the access points? So the most basic, and I would say least recommended option, would be to go under each access point and then manually configure that RF tag. We can do it. It's very useful when we are testing or managing few access points. But again, it doesn't scale when we want to keep things very automated. So one way we can keep those RF tags assignment a little bit more automated would be to use another configuration option that allows us to create rules on the controller based out of the access point name, so we can match the access point names with regular expressions, and based on the match, we can assign our needed RF tag. We can also assign other tags, of course, but this is one of the main usages of those regular expressions. So the next question that is going to arise from this is, how do we name our access points? All right? So at Cisco Live, we found a convention. We came up with a convention to name our access points in a certain way that it's coming useful to quickly recognize what are those access points used for, and then, of course, exploit the naming in those regular expressions. So we came up with a rule basically telling us from the access point name, the location type where the access point is installed, the number of that location, the level type, and the level number. All right? Those are specific to the venues where we are holding the event. So it's kind of customized for that venue, but we came up with this convention in 2023. We knew we were staying there 2 to 3 years, maybe a little bit more. So it was worth coming up with something customized. Maybe we will be able to reuse it for another venue, maybe not, but it's working pretty fine for us right there. There are a couple of other informations that are very useful to us when we are naming the access point. One is the antenna model, and one is the height at which that antenna is installed. Okay, those are the placeholders with the letters C and D that you see there. And then, of course, we also like to add a couple of letters to quickly identify the AP model we're using, and we leave some space for a unique identifier as well. So if I take a step back to the name of the access point I was using in those previous screenshots, these access points, we automatically know it's an access point installed in hall 1, level 1 of the event venue. It has a directional antenna similar to the 2566 D4M model that we are using for other access points too. And it is installed at medium heights. So for us, medium heights would be something around 4 to 6 meters. And of course, we also know it's a 9166 D1 access point. That's why that directional antenna. Okay, so if I now take back the regular expression I was also using in one of those previous screenshots, with that regular expression, and I will leave you a few seconds to check the correctness of that regular expression, but we can automatically select all the access points installed in hall 1 with those directional antennas installed at medium heights. Okay, so we can automatically assign the RF tags with the needed RF profiles with the needed minimum power level threshold for those access points not to go too low with their transmit power. Okay. Now, quick step back here. If configuring the controllers maybe takes a few hours, coming up with a naming convention, knowing that we were around 10 engineers thinking about it, it took, I would say, a few weeks. Okay. But we had some fun. It was a really nice discussion to have. It was really useful, and we are quite happy with the result there. Okay, so that's an idea. Maybe if you would like to apply it to your wireless networks as well, just try to put as less engineers as possible into the thinking. Okay, that will save you some time. Now, the last question that would arise from all of this is how do we name access points automatically then? Because we found a way to automatically, let's say, assign the access points the minimum power level, automatically tag them to inherit those minimum power level settings. Now, how are we going to automatic name the access point there? Well, that would deserve a whole new session, okay? So I'm not going to have the time to present it here. I will be more than happy to discuss about this off stage during the break. In few words, we are basically pulling the maps and the existing access point placement from the venue. We are importing it into Ekahau to then add our own access points as well. And thanks to the agility, let's say, of the Ekahau files, we can then export them again, rename things with external scripting tool, re-inject them into Ekahau to remodify them again, etc., etc. So we can do some export, scripting, re-import, and so on and so forth. And then, of course, we're going to take those maps, use them in our own monitoring tools, give them to the deployment team, etc., etc. All right. So this is just I think this is even a simplification from the team who worked on those tools, on how we automatically rename access points. But we can do those kind of automations so that then the deployment team can just pick up an access point, scan the barcode, install it, and it's automatically fed into the system that will automatically rename the access point. Okay? So, yes, it's never a perfect shape, but we can always find a way to make things fit, all right? Now, with that being said, again, I would be more than happy to share any additional details off stage, so do not hesitate to come and see me during the break. With that being said, I would like to thank you again for your attention, and I will leave the scene to Alexis for the next section. Thank you very much.